Complex number is one of the most complex topics in IIT JEE mathematics, and its complexity comes from the mixing that is happening with other topics of mathematics. So in order to make this one short video very interesting, I have divided this into two parts. In the first part, I talk about algebra of complex numbers, which usually students find moderately difficult. I have covered that part into 7 problem types to make your life extremely easy. I have taken questions from 2019 to 2023 and discussed how those problems can be solved in a very systematic manner. Now in this second part of this video, we are going to discuss geometry of complex numbers. It consists of remaining 5 problem types, where I am going to start my discussion with rotation, then I am going to move towards problems based on line, then circle, then conics, and end this discussion with a discussion on mixed problems based on geometry of complex numbers. This is one of those parts that students usually find very difficult. So I have tried to make your life very easy, and in that process I have covered most of the different kinds of PYQs that came from 2019 to 2023. In this video, I am going to systematically first tell you what is the concept behind the problems and then move towards solving those problems one by one. So let us start with it. Now let us start with next problem type, that is based on the concept of rotation. Let us first understand what the concept is and then see what kind of questions JEE has asked on. The concept is very simple. If I draw take two very simple points on the Argand plane, the first point is nothing but Z2 and the next point is nothing but Z3. These points are in such a manner that this angle is Z theta 2 and this angle is nothing but theta. So if I want to write Z2 in exponential form, it will be mod of Z2 e raised to the power I theta 2. Similarly, it will be nothing but Z3 mod e raised to the power I theta plus theta 3. Why so? Because this angle from here to here would be nothing but theta plus theta 2. Once I have written that, I can divide both of them. So Z3 by Z2 would be equal to Z3 mod by Z2 mod e raised to the power I theta plus theta 2 by e raised to the power I theta 2. So if I simplify this, I get a very simple expression. Z3 by Z2 is nothing but Z3 mod by Z2 mod e raised to the power I theta. Now what we are doing is this we have done when the third point, the point about which we are rotating it, is nothing but is at origin. Now I shift all of the system onto a point Z1, then this is how it looks like. And this is nothing but Z1. This is nothing but Z2 and this is nothing but Z3. So the same thing I can write again. This is nothing but theta 2, this is nothing but theta. But instead of Z2, now I will write Z2 minus Z1. And here also I can write Z2 minus Z1 mod e raised to the power I theta 2. For the another one, I can do the same thing. Z3 minus Z1 is equal to Z3 minus Z1 modulus e raised to the power I theta plus theta 2. And again, if you divide them, it becomes Z3 minus Z1 is equal to Z3 minus Z1 mod e raised to the power I theta plus theta 2. And Z2 minus Z1 into Z2 minus Z1 mod e raised to the power I theta 2. So if I divide it, it comes out to be Z3 minus Z1 by Z2 minus Z1 is equal to Z3 minus Z1 mod by Z2 minus Z1 mod e raised to the power I theta. And this is known as the rotation formula. Now let us look into this first question based on rotation that came in 2022. If you look into this question and if I draw a small diagram, the question says that there is a complex number Z1 and the value is 1 plus 2i. And this is your complex number Z1. Now what we are saying is there is another complex number Z2 in second quadrant because they have given real part of Z2 is smaller than 0 here. And if I join, this is O, this is A, this is B, and this angle is given as 90, this is hypotenuse and this is the isosceles triangle, so OA is equal to AB. That would mean this angle BOA will be nothing but pi by 4. And also we know the value of OA. OA is nothing but mod of 1 plus 2i, that comes out to be root 5. You can observe here, if OA is root 5, AB will also become root 5. And since OB is nothing but hypotenuse, it will become root 10. Pythagoras theorem, a square root of a square plus b square is equal to c square. Once you do this, now we can find Z2 using rotation formula. So Z2 by Z1 is nothing but Z2 mod by Z1 mod e raised to the power I times pi by 4. If I simplify this, my Z2 z1 is 1 plus 2i, and this is root 10 by root 5, and this is 1 by root 2 plus I into 1 by root 2. And if you simplify this, z2 becomes nothing but 1 plus 2i into 1 plus I. And if you simplify this, it becomes nothing but 1 plus 3i minus 2, or minus 1 plus 3i, and it is in link with what is given in the question that it needs to be in the second quadrant. So it is there in the second quadrant. So by doing this, you have found the value of z2. Now all we need to do is basically check the options. So if you find the argument of z2, option A comes out to be correct. This is fine. If you find mod of z2, option D is also correct. Now what they are asking is which of the following is not true. So this is true, this is true. Now let us check B and D options. So if I check my B option, for that what will I have to do is I will have to find z1 minus 2z2. It comes out to be nothing but 1 plus 2i minus 2 times minus 1 plus 3i. And if I simplify, it becomes nothing but 3 minus 4i. So if you find the argument, this B option also comes out to be correct. So by elimination, you can say D option is wrong, or in our case, the correct answer. And or you can still find the value of 2z1 minus z2. So 2 times 1 plus 2i minus of minus 1 plus 3i. If you simplify this, this is 2 plus 4i. And this becomes plus 1 minus 3i. And if you simplify, this is nothing but 3 plus I. And of course, it is not equal to root 5. Hence, this D option is wrong, and hence our correct answer. Now, next, let us look into a very interesting question that came in 2023. In this question, what they are saying is there is a complex number z1, and this z1 lies in first quadrant. It is nothing but 5 plus 4i. What we are doing is we are rotating this by 90 degree in anti-clockwise direction. And if I do so, I get my W1. Now, there is another complex number the question talks about. Now, this is also in the first quadrant. So, if I try and draw it, it is 3 plus 5i. So, this is 3 plus 5i. And I am rotating it in clockwise direction like this. So, now the value of this is nothing but W2. What they're asking is what will happen to W1 minus W2, and the argument of that part. So let us first find W1. So if I want to find W1, W1 by Z1 is nothing but W1 mod by Z1 mod into e raised to the power I times pi by 2. Now you can see that since the moduluses are equal, it becomes e raised to the power I pi by 2, and this is equal to I only. So the value of W1 is nothing but 5 plus 4i into I, which comes out to be minus 4 plus 5i. Now we can do the same kind of calculation for the W2 part. Here also, if I apply rotation, it is nothing but W2 by Z2 is nothing but W2 modulus by Z2 mod e raised to the power minus I pi by 2, because now the direction is reversed. Now we are going in clockwise direction, so angle will become minus pi by 2. If I put these values, again mod of Z2 and W2 are equal, and Z2 was equal to 3 plus 5i. E raised to the power minus I by 2 will become minus I. If you simplify this, the value of W2 comes out to be 5 minus 3i. And now if I find W1 minus W2, it is nothing but minus 4 plus 5i and minus 5 plus 3i. So it becomes nothing but minus 9 plus 8i. You can see that this is in second quadrant, and if I find the principal argument, it will become minus pi minus 10 inverse 8 by 9. So my option C becomes correct. So let us look into a very interesting question that came in 2008. In this question, all we need to do is trace the path of a particle. So if I make a coordinate plane, and you can see that I can solve this question by converting this question into a question of coordinate geometry. So what they're saying is, instead of point Z0, where it started from, let us take the initial point as nothing but 1, 2. Now this is my Z0 point. What we are saying is the moves first horizontally away from the origin by 5 units. So it is moving like this, 5 units. If I do that, this point will become nothing but 6, 2. Then it moves vertically away from the origin by 3 units and reach point Z1. So it has reached here Z1. And by this time it is 6, 5. Next, what the question says is this starts moving in the direction of I cap plus j cap. You can see that since the x and y coordinate are equal, what we can say that this moves at an angle of 45 degree here onwards. Now it is moving root 2 in this direction. That would mean the effective movement in x and y direction is 1, 1. So now this point as a result will become 7, 6. So this is where we have reached. Now what they're saying is once you have reached this point, you need to rotate it by in anti-clockwise direction by pi by 2. So now let us go back to complex number. So from complex numbers point of view, we are at 7 plus 6i. If I want to rotate it in anti-clockwise direction, so I can write this as mod of z by 7 plus 6i ka mod into e raised to the power I times pi by 2. To do this, you know that this part, both the magnitudes are same. So z becomes 7 plus 6i into I, that becomes minus 6 plus 7i. And that matches our option D. So you can, in this manner, very imaginatively convert a question to a question of coordinate geometry, solve and again convert it to back into a question of complex number. Now let us move on to the next problem type, that is line. Before we start line, we should understand a very simple concept of complex number as vectors. What does this idea means is, let us say we have a complex number z and we have a complex number z1. So if I join this line z minus z1, it acts like a vector in Argand plane. Now this idea is very important because we are going to use this idea to write different forms or equations of a straight line. Let us start with that. So if we have a straight line, let us say the first way of expressing it would be using argument. If I say argument of z is equal to pi by 6, what does this mean? This means all those complex numbers, now you can see that since we are writing z, there is inherently z minus 0%. If I am taking this z, this means I am connecting this point to the origin. And then this vector should be at an angle of pi by 6. So you can see that this will represent a ray starting from origin going till infinity at an angle of pi by 6. So like in a straight lines, we have a concept of line and line segment. In this complex number, we also have a concept of ray, and JEE has used this beautifully in JEE mains and advanced questions. If I move towards next idea, that is if I try to move this point from origin to some other point. So if I write like z minus a, argument of this equal to pi by 6, what will this mean? So if I again write this, this would mean now your ray starts from a point A and this z, this will become our vector. Now this is at an angle of pi by 6. You can see that the starting point is now shifted from origin to point A. Now if I take this idea further, what I can do is I can also represent different parts of a straight line. And what does that mean? Let us say that we have this z1 here and z2 here. So you can see that there is this one part of the straight line, that is the z1, one after z2, and let us say another part of this line lies between z1 and z2. So you can see here that there is this first part that is before z. So if I take a point here, if I take a point here, so z minus z1 is this vector. And if I write z minus z2 vector, that will also be in the same direction. What we can see is the angular difference between z minus z1 and z minus z2 is equal to 0. Also, if we have considered this point on this side, the same kind of relationship will still hold, because again the angle between z minus z1 and z minus z2 will be equal to 0. So this also represents equation of straight line, but it does not represent the middle part. It expresses the part that is beyond z1 here and z2 there. If I want to write this blue part, how to express this? So if I take any 2 points here, let us say that now I am considering a point z here. So in this new scenario, if you write argument of z minus z1, and if we subtract argument of z minus z2, you can see that now the difference between that will be equal to pi. So this middle part will come when the difference between both the vectors is equal to pi. So it is a very beautiful and simple concept. Another way of expressing this comes using this determinant form like we used to do in area. So this is a lot of similarity with that area concept. If you see, we have written z bar 1, z1 z1 bar 1 and z2 z2 bar 1 equal to 0. And if you open it up, what you will get is you will get a general form of a straight line that looks something like this: a bar z plus az bar plus b equal to 0. About this form, there is one more interesting idea, that if I express this in this form, z is equal to minus a by a bar z plus b, you can see that this looks like nothing but a kind of a slope, and this part is also known as complex slope. We can also write this as ai by ai bar. The next type of form of straight line and directly comes from the concept of vectors. So if I'm writing this z minus z1 into k times, where k is a real number, z1 minus z2, so it is like writing two parallel complex number, parallel vectors, like b vector is equal to lambda vector. So we are trying to borrow this idea from vectors directly. When we start treating it like vectors, it will start acting this manner. And if I simplify, I get my this parametric form. Now, if I simplify any of these forms, it can be expressed into this general form, that is a bar z plus az bar plus b equal to 0. I'm not going to derive it here. That derivation you can study. Important thing is a vector that is parallel to this line can be written as ai. So directly from here, we can get a vector that is parallel to this line. Now, what if I do z minus z1 mod is equal to z minus z2 mod. So now if you simplify this, what you are going to get is those complex numbers which are at an equidistance from z1 and z2. So this becomes the equation of perpendicular bisector. So, and this has been used multiple times when we write z minus I mod is equal to z minus 2i mod. What would this mean is a line. So if I mark I and 2i, so this is my 2i and this is I. So a line which is equidistant from these two lines. So it will become a perpendicular bisector like this. So without doing anything, you can write this equation as y is equal to 3 by 2. Or all those points that has imaginary number equal to 3 by 2. Now, if we move towards the problem, the first most simple problem was asked in 2019. Directly equation of angle a perpendicular bisector is given to us. Z minus Z1 mod is equal to Z minus Z2 mod. And they're asking what is the locus. So directly you can say a line. Now a line. So line is coming. And there are two kinds of line they are talking about. Now if you mark these points, you'll be able to understand what kind of line. So if I mark my first point, that is I. And another point, that is 1. So we are talking, if I join these 2 points, we are talking of an angle bisector. So this line is going to be something like this. So the slope is going to be +1. Hence B option becomes correct. Now, instead of doing this, you could also have put z is equal to x plus iy. So it would have become z plus iy minus 1 mod is equal to x plus iy minus 1 mod. So this becomes nothing but x square plus y minus 1 whole square root is equal to root of x minus 1 whole square plus y square. So if you simplify this, it is x square plus y minus 1 whole square is equal to x minus 1 whole square y square. And if you simplify, what you will get is nothing but x square plus y square minus 2y plus 1, x square minus 2x plus 1 plus y square. So your x square y square will get cancelled out. Your 1 will also get cancelled out. And what you are getting is y equal to x. That is nothing but a straight line with slope 1. So this is another method of solving the same question but without geometry. Now next problem type is based on the concept of circle. So if I look into the basic equations of circle, the first and the foremost equation is very simple. If we have something like z minus z1 or z0 mod is equal to r. Now you can see that what we are saying is all those points which are at an equidistant from a point z0 and the distance is equal to r. So z0 will become the center of the circle and r will become the radius of the circle. So if I represent it in a form of a diagram, this is how it looks like. Now we can see that if I take this mod and put here greater than r, then we are talking about those points which are at a distance from z0 which is greater than r. So this will represent points outside the circle. So if I try and sketch them on the diagram, we are talking about these points which are outside the circle. Now if I move further and if I write this z minus z0 mod is smaller than r, then what we mean is those points which are lesser than r distance from z0. That would mean that the points which are inside the circle. So if I try and shade it out, this is how the points are going to look like. Fine. So equal to r would mean on the circle, greater than r means outside the circle, and smaller than r would mean inside the circle. Now the next kind of equation of a circle can be represented by writing it as z minus z1 by z minus z2 mod is equal to k. See here k, this need not be equal to 1. So what we are saying is k is greater than 0, and obviously because it is value of modulus, and it is not equal to 1, because in case of 1, when k is equal to 1, it will become perpendicular bisector. This we have already done, and a 2019 question came on the same idea. What we are here saying is if k is greater than 0, if k is greater than 0, and if I simplify this, this becomes a circle. You can easily prove this by putting z is equal to x plus I. The next idea is based on Pythagoras theorem, that if we have a point z like this, that this is nothing but z minus z1 mod, this side will become z minus z2 mod, and this side is nothing but z2 minus z1 mod, and this is following nothing but Pythagoras theorem, like z minus z1 mod whole square plus z minus z2 mod whole square is equal to z2 minus z1 mod whole square. So you can see that now it has become a part of Pythagoras theorem. So if it satisfies Pythagoras theorem, this would mean this angle that we are talking about is nothing but 90 degrees. So this will always happen when this point lies in a semicircle. So what we are seeing is this form represent a circle, and not any circle, a kind of a circle for which the extremities of diameter are given to us. So all the points on the circumference of this circle are going to satisfy the equation or the condition that is given to us. Now we can express the locus of major and minor arc using complex numbers. Now let us understand how. So let us say if I take argument of z minus 1 by z minus 2 is equal to pi by 6. Now let us see that, let us understand what this is going to express. Okay, so let us mark these points on the Argand plane. So this is 1, this is 2. So what we are saying is, if I take a point z here on this side, then this vector that connects z to z1 is nothing but z minus z1 vector. And if I connect this point to z2, this vector is nothing but z minus z2 vector. So what we are saying is, if I start from z1, z minus z1 and go towards z minus 1, the angle would be plus pi by 6. So if I do that here, this will be wrong, because if I'm going from z minus 1 to 2, the angle is clockwise direction. So this angle is negative. So this cannot be on this side. But if I take it on the other side, here, now this is z. So this becomes z minus 1. This becomes z minus 2. So now if I'm doing this, now we can see that if I go from z minus 2 to z minus 1, it will be in positive direction. So this angle can be pi by 6. Also, if I draw this locus, all that point that are going to do this will come out to be a circle, because there is a property that if I take any point on the circle, this angle always remains same. We are using this property that this angle will not change. And if this angle is actually smaller than pi by 2, or between 0 and pi by 2, then this arc is going to be a major arc. So when we are saying this pi by 6, this would mean it is a major arc. And the direction will change. Now here, instead of this, if I write nothing but argument of z minus 1 by z minus 2 is equal to minus pi by 6, the orientation will change. Now we are talking about this major arc. And the below part is not coming, the dashed part is not there, only the solid part is there. Because now the angle is in the opposite direction, anti-clockwise and clockwise, that you need to take care of. This is very important, because JEE Advanced has made question on similar kind of idea. Now that question can be asked in JEE Mains. Now if I change this concept a little bit, and if I write argument of z minus 1 by z minus 2 is equal to 2 pi by 3. Now we can see that the angle is no more between 0 and pi by 2. It is between pi by 2 and pi. So what will happen is, in this case, we are going to get major arc. So what is happening here is the point remains same. But you can see now this arc is minor arc. So between 0 and pi by 2 major arc, between pi by 2 and pi minor arc. So everything else is same. Now angle you can also see here, we are going from here to here, so it is positive only. And if I change this question a little bit and write here argument of z minus 1 by z minus 2 is equal to minus 2 pi by 3. Sorry, yeah, correct. So if I do this, again this will 1 and 2, but it will come on the other side, because now you can see that from z minus 1 to z minus 2, I am moving in a negative direction. So still it is a minor arc, but the orientation changes. Now if I want to express a semicircle, then you can see that instead of writing a number between 0 and pi by 2 and pi by 2 and pi, I am going to write pi by 2 only. Now interestingly, what is happening here is, again, if I write it here in the form of an example, z minus 1 by z minus 2 is equal to pi by 2. Now you can see that if I draw here, this is 1, this is 2. So the angle between them needs to be pi by 2. So what we are talking about is, we are not talking about this top part of semicircle. We are talking about the bottom semicircle. In this case, we are getting only half of the circle, and that to bottom half. If I want to get the upper half, what I will do? I will write argument of z minus 1 by z minus 2 is equal to minus pi by 2. In this case, I will get the top half of the same circle. So it is an equation of semicircle. Now if you look into the next idea, it is nothing but the general equation of a circle. So what you can do is, you can take the same equation that we wrote earlier, z minus z1 z minus z naught mod is equal to r. And if I square it on both the sides, I can simplify this. This will become z minus z1 z naught z minus z naught bar is equal to r square. And if you simplify this, it comes out to be an equation of this form. So if you simplify this, it will become z bar plus a bar z plus a z bar plus b equal to 0. So this becomes nothing but the general equation of a circle. And here, if you compare, and once you get both the equations and compare, you will get the center of this circle. So if I draw this circle, the center of this circle will be nothing minus a. And the radius of this circle would be nothing but root of mod of a whole square minus b. Now this is not very difficult. No, not such a difficult question is going to come at means. So you just have this idea that whenever you look into this kind of an equation where z in the equation of a straight line. So if you remember that this part was nothing but the equation of straight line. In that, if I add this one more part, and this is very important, if I add this one more part, it becomes the equation of circle. If you remember this much, when this kind of equations come in the question, you will be directly able to identify that, oh, it is a circle, and then you can solve it. Now this first question is again very simple, that came in 2020. If you look into this question, see, if I look into this first part, you can see that it is nothing but z minus I mod is equal to z plus 2i mod. And once you look into this, you should remember the idea of perpendicular bisector. What we understand is if I plot it down and represent the top point as I, the bottom point as minus 2i, it is talking about a perpendicular bisector of this line joining these 2 points. So that is going to pass through here at a point nothing but minus 1 by 2i. So this is quite simple to solve if you remember the concept. If you do not know the concept, then put z is equal to x plus iy and then solve. That also will give result, will take more time. Now if you recognize the second idea, it is nothing but equation of circle. Mod of z minus z naught equal to 1. So you can see that your z naught is nothing but 0 and your r is nothing but 5 by 2. So they are talking about a circle that is like this. Radius of this circle is nothing but equal to 5 by 2. Now, if I solve them simultaneously, I'm talking about a point on this circle with coordinate x and y coordinate as minus 1 by 2. So if I write the equation of the circle, it is nothing but x square plus y square is equal to 5 by 2 whole square. The value of y I know. This is nothing but y square will become 1 by 4. This is 25 by 4. The value of x square comes out to be 24 by 4 or 6. Once you have got this, in the third part or in the third logic, what they're asking is value of this part. Now z you know. What is z? It is nothing but plus minus root 6 minus 1 by 2. So put it here and find the answer. So if I put and find the answer, it becomes root 6 plus minus 1 by 2 into I plus 3i mod. And if I simplify this, this comes out to be 7. Quite a simple question. If you just identify, so see, my point of telling you equations was not that you should remember all the forms. Definitely it is better to remember all the forms, but even if you can identify by looking into question what kind of geometrical figure we are talking about, we have won the battle. If I move on to the next question, it is nothing but a question of coordinate geometry asked in the garb of complex numbers. So our idea is very simple. Convert this question into a question of coordinate geometry and then solve it. This is going to be our main method of solving questions involving geometry of complex numbers. Now, why us knowing those complex equations of circle are important or lines are important? Because we can understand the coordinate form faster. Like in this case, what they're saying is if I look into whatever is inside the mod, z minus 3 minus 2i, then they're putting mod and is smaller than 4. This would mean a part of a circle whose center is at 3, 2 and radius is 4. Whatever is inside the region, that will happen. And if I put greater than 1, this part would mean the region outside a circle of radius 1. So if I draw both of these on the same circle, it is going to be region between two circles. So what we have is this bigger circle and then we have this smaller circle. These are concentric because their center is given as same as nothing but 3 minus 2 and this radius is 1 and this bigger radius is nothing but 4. And now what we are talking is the region that is between these two circles. So we are talking about this region. Okay, so this is important for us to interpret in this manner. Now see, you can see that after this I have made it a question of coordinate geometry. Why? Because now what they're asking was number of elements in Z for which both the coordinates x and y coordinates, that is a and b in this case, would be integral in nature. For solving this question, what I will do as a student is I understand that whether I write it from 3, minus 2 or 0, 0, it will not change. So what I will do from coordinate geometry is I will shift to the origin. So instead of writing this, let us write the center as 0, 0. It is not going to make any difference in the answer. Why? Because 0, 0 is also an integer and 3, minus 2 is also an integer. So whatever the number of points, they are not going to make any difference. Now once we have done this, it has simplified our job to a large extent. Now, how to count number of integral points? There is a method for that. What is the method? If I draw a line, we can start from drawing line at the center. Now this point we know is going to be nothing but 1, 0, and this point is nothing but 4, 0. So what I'm going to do is, now let us simplify this equation into this equation. We want this to be between 16 and 1. I've shifted my origin to 0, 0, so this has gone away. And because of that, I was able to write this equation. Now, because after this simplification, this question becomes extremely easy. Now, what you can do is, for finding points at this where the y coordinate is equal to 0, just put y is equal to 0 here. If I put y is equal to 0, what happens is my x square lies between 1 and 16. So you can see that your x can take a value like -3, -2, 3 and 2. So I'm not considering value that is equal to 1. So between 1 and -1, that value cannot be considered. So what we are getting corresponding to these 4 values is 4 points. So from here we have got 4 points. Now similarly, if I put y is equal to 1 here, what I'm going to get is x square plus 1 lies between 16 and 1. So my x square lies between 0 and 15. So the possible value when this can happen for x is nothing but, we need to take 1, -1, then 2, -2, and 3 and -3. So you can see that in this case we have nothing but 6 values. Now you can see if I'm drawing a line at 1 here, not like this, let's draw more up to the scale, like this. There is one line below also possible. So corresponding to this there are 6, and if I would put my y is equal to -1, I will get another 6 points, and that is nothing but this below line. And now I need to go till 4. So if I put again y is equal to 2, correspondingly this becomes 1 is x square plus 4 is smaller than 16. So from here what you're getting is x square is smaller than 12. So the possible values of x are nothing but 0, 1, 2 and 3. So again what we are getting is 4 points. And now what you can observe here is, we have got this 4 points, but not just 4 points. Corresponding to this, a value of x can be negative also. So -2, -1 and -3 is also possible. So these 3 more points will make it total 7 points. Now this can also happen for y is equal to -2. Considering that, we also need to multiply by 2. And in the last part, what we can do is we can put here y is equal to -3 or +3. So +3 and -3 both we are going to put. Now let us put either of these values. So x square plus 9 is smaller than 16 and 1. So only this side would give us a valid result, will be smaller than 7. So possible values of x are nothing but 0, 1, 2. Because at 3 it will become 9, and correspondingly -2 and -1. So you can see that again 5 values. Since we are also considering for y is equal to -3, and we will have to multiply by 2 here. So now let us sum it up. So what we have got for the first case was 4. For next case, it was nothing but 6 into 2. For the next case, 7 into 2. For the last case, it is again nothing but 5 into 2. If you sum it up, it comes out to be 40. That is nothing but answer of our question. Now again, this is a very simple question that was asked in 2023. Now if you remember this equation, I told you in the starting that if we have something like z minus z1 mod by z minus z2 mod is equal to k, it is bound to be a circle if k is greater than 0 and k is not equal to 1. Here the value of k is given as 2. So after you remember this result, you can instantly understand that this locus is going to represent a circle only. And they have given it also that the center and the radius of the circle are nothing but alpha, comma, beta and gamma. Find the value of this expression. So all we need to do is find the equation of the circle, get the center and radius and put it in this variable or the expression that they're asking us to do and find the value of it. What we can do here is put the value of z as x plus iy and take mod. If I do that, this is what I'm getting, x plus iy minus 3 mod. And if I do it, it is x minus 2 whole square plus y square. And this is nothing but root of x minus 3 whole square plus y square. And if I simplify, what I get is x square minus 4x plus 4 plus y square. And this becomes 4 times x square minus 6x plus 9 plus y square. And if I simplify this, you can see that we will ultimately get ultimately get 3x square plus 3y square minus 20x, and then 36 minus 4 will be 32 equal to 3. And if you divide it by 3, what you get is nothing but a general equation of a circle which looks like this. Once you have done this, now if you find the center of the circle alpha comma beta, it is nothing but minus g comma minus f. That comes out to be nothing but 10 by 3 comma 0. And if I want to find the value of r, or the radius, or the gamma in this case, it is nothing but root of g square plus f square minus c. So that comes out to be nothing but 10 by 3 whole square minus 32 by 3. Once you do this and figure out the value of gamma, it will come out to 2 by 3. And now we have got the value of alpha as nothing but 10 by 3. We have got the value of beta, that is nothing but 0. We have got the value of gamma, that is 2 by 3. If I put it in alpha plus beta plus gamma into 3, the answer comes out to be 2. So it is quite a simple question. If you just put z is equal to x plus y, you will get the answer. Now this next question that was asked in 2023 is a very interesting question because it is based on diametrical form. So when we were doing the basic equation, we came across this equation wherein we were using Pythagoras theorem. So what we did was basically we took this z1 and z2 as extremities of diameter and we connected it with one of the points on the circumference. And then we said that if I take this point as z, then the equation of this can be written as mod of z minus z1 whole square, z minus z2 whole square. And this will be equal to z2 minus z1 mod whole square because this angle is 90 degree and Pythagoras theorem will get satisfied. And here we also told that this z1 and z2 are nothing but extremities of diameter. Now instead of giving this, what they have done is they have replaced this z1 and z2 by alpha and beta. So instead of writing z1, z2, they have written here alpha and beta. So this becomes alpha, beta, alpha, beta. Then ideally this should become alpha minus beta whole square. But instead of writing this, which is nothing but 2 times radius, that is nothing but diameter, instead of writing this, they have given this value as 2 times lambda. So what we can write from here, 2 times lambda is nothing but 2 times r whole square. Because alpha minus beta mod is nothing but twice of radius or diameter. Once you got that, what they have also given is the value of lambda radius, that is lambda minus 1. So if I put it here, it is 4 times lambda minus 1 because here r is nothing but equal to root of lambda minus. If you put these values here, you can see that you can cancel out 2. Your lambda will be equal to 2 lambda minus 2, or lambda becomes equal to 2. If lambda is equal to 2, what they are asking is value of alpha minus beta ka mod. And we know that the square of this was equal to 2 times lambda. So alpha minus beta ka mod ka whole square is 2 into 2. So the value of alpha minus beta modulus comes out to be 2. Now let us look into this next question of 2023. The question is quite simple. It talks about a circle whose center is given as nothing but 1 by 2 comma 3 by 2. So you can see that I am converting this question into a question of coordinate geometry in real time. And that is the technique of solving such kind of geometrical questions. So this is given. And now what they're saying is the radius of this circle is equal to 1. That is fine. Apart from that, they have given that there is a point z1 equal to 1 plus I. If you find the location, it would be somewhere here. So this point becomes 1 comma 1 in coordinate geometry. Now they want us to find a point z2 which are related by this relation. So if I find z1 minus z0 ka mod, and it is nothing but the distance between the center and this point z1. So I can apply my distance formula and it will become 1 by 2 whole square plus 1 by 2 whole square. And this comes out to be 1 by root 2. We have done this. Now once we have done this, now what they're saying is z2 minus z0 mod is nothing but reciprocal of this. So this will become nothing but root 2. So now what we want is basically a point that lies on the line joining z0 and z1, but is at a distance root 2 from the center. Okay, so now we have two scenarios. One, the point can be here, another the point can be here. So let us consider both the scenarios. Let us take case 1. In our case 1, what is happening here is my point z0 is here, that is 1 by 2 comma 3 by 2, and my point z1 is here 1 comma 1, and z2 is on the other side. And let us say that this point is x comma y. Now if this distance is z2 root 2 and this is 1 by root 2, if I find the ratio, this will be 2:1. And next, if I apply the section formula, what am I going to get is x plus 2 by 3 is equal to nothing 1 by 2, or the value of x comes out to be 3 by 2 minus 2, that is nothing but minus 1 by 2. Similarly, if I put y plus 2 by 3, it will be equal to 3 by 2. The value of y comes out to be 9 by 2 minus 2, that is nothing but 5 by 2. So this is the first case that we have figured out. In the next case, or case 2, I can do similar kind of calculation, but in this case my z0, z1 and z2 are on the same side of the line. So in this scenario, this distance is root 2 from here to here, and this distance is 1 by root 2. So if I find the distance between z1 by z2, it is nothing but root 2 minus 1 by root 2, and you can see that it will also come equal to 1 by root 2. So if you look into these ratios, now once you figured this out, now what is happening is, after this basic calculation, this distance is also 1 by root 2 and this distance is also 1 by root 2. The ratio between them is 1:1. So here z1 is midpoint between z0 and z2. So if I use this logic, then what I am got is, again if I apply distance formula, assume as z2 as x comma y. So x plus 1 by 2 will be equal to 1. So the value of x comes out to be 3 by 2. And y plus 3 by 2 comes out to be 1. So y comes out to be nothing but minus 1 by 2. Sorry, plus 1 by 2. So from the first point of view, the point is nothing but the value of z2 mod would be nothing but 1 by 4 plus 25 by 4. So it is nothing but root of 26 by 4. Wherein if I look into my second case, the answer comes out to be 9 by 4 plus 1 by 4 ka root. That is nothing but root of 5 by 2. So now what they're asking is mod of z square. So the minimum of both of these values is root 5 by 2. That comes out to be option B. Now let us look into this very interesting question that was asked in 2022. In this question, they have given two equations. One clearly and distinctly is the equation of a circle that has center at 3 and the radius is 1 by 2. If I look into the other equation, this is a messed up equation because there are many mod signs put into a single question. How to maneuver through such kind of equation or question? So in such kind of question, your technique should be centered around removing the modulus sign. If I want to remove the modulus sign, I will square it and will use the property that mod of z square is equal to zz bar. So if I do that, this is z0 minus z2 plus 1 and then z2 bar minus z2 plus 1 ka mod, and on the right hand side I get z2 plus z2 minus 1 mod into z2 bar minus z2 minus 1 mod. And if I simplify it, what am I going to get in this scenario is, it will become z2 bar plus z2 plus z2 bar with a minus sign, and then in multiplication we will have z2 plus 1 mod, and towards the end what we have is z2 plus 1 mod whole square. On the right hand side what we will get is same thing, z2 bar, but instead of minus sign we will have z2 plus z2 bar ka mod. In this time we are having positive sign, and the last part is nothing but z2 minus 1 mod whole square. So you can see that the first term gets cancelled out. Once we have cancelled this first term, we have this second term that can be simplified, and if we simplify and write this, what we are getting is minus z2 plus z2 bar in z2 plus 1 mod, plus this can be written as z2 again zz bar, so z2 plus 1 in z2 bar plus 1, and then we have z2 plus z2 bar in z2 minus 1 mod plus z2 minus 1 into z2 bar minus 1. And again if we simplify this, what we are getting is minus z2 plus z2 bar plus z2 plus 1 ka mod, plus this also can again multiply, simplify and cancel out, and ultimately we will be left with z2 plus z2 bar, and on the right hand side z2 plus z2 bar z2 minus 1 mod, and again if you simplify this, minus of z2 minus of z2. So we can see that in all of these z2 plus z2 bar, this equal to 0 is one solution. So what we have Z2 plus Z2 bar equal to 0 as one solution. And another thing that we have here is nothing but Z2 plus 1 ka mod with a minus sign is equal to nothing but plus 1 is equal to Z2 minus 1 ka mod plus minus 1. And if I simplify this, I get a very simple statement, that is Z1 minus 1 Z2 minus 1 ka mod plus Z2 plus 1 ka mod is equal to 2. Now, interestingly, what is happening in this question is we are getting two different solutions. Now, if I consider the second one, I can also consider the first one. If I consider the second one, something very interesting happens. So if I try and draw it, what is happening is, see, this will represent the locus of those points whose distance, if I take from 1 and 1, sum comes out to be 2. Now, if I try and draw this second locus on the number line, and it will be nothing but a straight line segment between minus 1 and 1, because if I take a distance, take any point between Z1 with minus 1 and 1, the distance of that point from minus 1 to 1, if you add it down, it will always come out to be 2. So this becomes nothing but equation of a line segment between minus 1 and 2. And another thing that they have given is nothing but the locus thing, that if I draw is nothing but a circle whose center is at 3 and radius is 1 by 2. So this point, if I look into this point, is nothing but 5 by 2. So the minimum distance between these two is nothing but this distance. And this distance comes out to be 5 by 2 minus 1, that is 3 by 2. If you want, you can also check about this one more locus that is given. But see, you can see that from this diagram, it is going to lie on this imaginary axis, and the nearest distance will come corresponding to origin. And that distance would be 5 by 2. So even that is not the minimum answer. So it will become one of the maximum, not maximum, but somewhere between minimum and maximum answers. Definitely not the minimum answer. Now, this is a very interesting question that came in 2023. In this question, what they are saying is, this is an equation of circle given. Now, you can see that just by looking into it, we cannot figure out. So we can put z is equal to x plus iy. If I do so, it becomes x minus 1 whole square plus y square is equal to 4 times. I have squared on both the sides. If you're not comfortable doing the square, you can write it down and then you can do the square into root of x square plus y square. So once you do it, it becomes x minus 1 whole square plus y square is equal to 4x square plus 4y square. And if you do this, what we are getting is x square minus 2x plus 1 plus y square is equal to 4x square plus 4y square. And if I simplify it, what I get is thrice of x square plus thrice of y square plus 2x minus 1 is equal to 0. And if I divide by 3, it is x square plus y square plus 2 by 3x minus 1 by 3 equal to 0. So we are looking into a circle. If I draw it up to the scale, we are looking into a circle that looks something like this, whose center is at a point 2 by 3, comma 0. And if I, minus 2 by 3, comma 0. And if I look into its radii, it is nothing but root of g square plus f square minus c. So becomes 4 by 3 plus 1 by 3. If you look into this diagram, what you will understand is, if I draw up to the scale, this is how it looks like. And we understand that something like this is going to happen. So if this happens, what they have given us is basically, if I take the point on this line, on this circle, then it is being such a manner that a into b is smaller than 0. That would mean either it is in this quadrant or this quadrant. If this happens, important thing is what they're asking is, what is the value? What is the possible value? So now here you can see that since the value of a, we can have value a between minus 1 to 0. It is possible to take these values for a. So what will happen is, your 1 plus greatest integer function of a, this part will become 0. And because of this, your C option is definitely possible. Now let us look into this very simple question that came in 2022. But a very tricky one also, because here the coordinate geometry part and is so strong in this question. If you look into this first circle that they're talking about a circle whose center is nothing but 3, minus 2. And the radius is nothing but n by 4. So look into this another circle. The center is nothing but 2, minus 3. And the radius of this circle is nothing but 1 by n. So what they're saying is, what they have written and what it means is, they should not intersect. In simple language, if they intersect, then the deal is broken. Otherwise, it is fine. So for this to happen, we understand that D needs to be greater than R1 plus R2. This condition is there. If you find D here, D comes out to be root of 1 square plus 1 square. D is nothing but distance between center, this distance. We are applying distance formula, it comes out to be root 2. If I find R1, they have given this value as n by 4. If I say R2, they have given this value as 1 by n. So all we need to do is simplify this equation and find the corresponding values of n, and that is going to be the answer. If I do so, what I can write is root 2 is greater than n by 4 plus 1 by n. Now if I solve this further, what I'm going to get is n square minus 4 root 2n plus 4 is smaller than 0. And if I solve this quadratic, it comes out to be 4 root 2 plus minus root of b square, that is 34, minus 4ac, that is 16, by 2a. 4 root 2 plus minus 4 by 2, which I simplify, it comes out to be 2 root 2 plus minus 2. So our value of n lies between 2 root 2 minus 2 and 2 root 2 plus 2. For the first scenario, it is 2 into 1.414 minus 1. Then the second one, if I take 2 common, it is 1.414 plus 1 into 2. So the value of n in this case lies between 2 into point, so somewhere around 0.8 to 2.4 into 2 would be 4 point something. So the possible values of n are nothing but 1, 2, and 1, 2, 3, and 4. Hence the answer becomes option D, 4. Now this very interesting question was asked in 2022. What this question says is, there is this one locus and we can clearly identify this is argument of z minus 1 by z plus 1 is equal to pi by 4. And this is nothing but an locus of a major arc. Major arc because this angle is pi by 4, that is between 0 and pi by 2. And this one, another one, is nothing but a circle. Now this is quite simple to do. This we can easily do. So let us first move from the difficult part, that is major arc. So if I try and plot these points on the Argand plane, what is going to happen is, one point is minus 1 and 1 is 1. So if I start from z plus 1, so let us say that this is the point z. And if I start from here, so this vector is nothing but z plus 1 and this vector is z minus 1. So what is happening is, if I start from z plus 1 to z minus 1, this angle needs to be positive pi by 4. So we can definitely say that it is going to lie on this side. And if I draw the arc, this is how the arc looks like. So if I draw a little bit better diagram in the form of a circle, this is how it looks like. So we are talking about this upper part, major arc of the circle, that is this part. And now you can see that this point is minus 1, 0, this point is 1, 0. So the center of the circle, if I try and find, if this angle on the arc is nothing but pi by 4, this angle at the center would be nothing but pi by 2. If I drop a perpendicular from here, this angle, half of this will become again pi by 4. Now this is 1 from here to here. Since this angle is pi by 4, this will also become 1. Okay, so if I want to write the coordinates of the center of this circle, the center of this circle is at 1, 0. If I want to find the radius, it is nothing but root 2. Because angle we know in this triangle is 45 degrees. So once you have figured this out, now we have got a circle, we've got the whole picture. And now, if you look into another circle that is with us, so the center of the another circle is at this point, and the radius is 3. Now this topmost point, even if you find, this would be 1 plus root 3. So 3 would be still bigger. So we can see that this another circle completely circumscribe our current circle. Something like this. And there will be no common point of intersection. Hence the answer becomes C. If I look into this next question, it is a very simple question based on locus. So the first part of the locus says that if you have mod of z plus 1, this needs to be smaller than z minus 1. What does this mean is, if I am considering a point in the Argand plane, let us mark this point as minus 1 and this is plus 1. So what we are saying that if I consider a point here, it needs to have more distance from 1 compared to minus 1. That would mean if this is the angle bisector between minus 1 and 1, this point needs to lie closer to minus 1 compared to 1. Only then the distance with 1 would be more. Now if I look into the next part says that this locus, that is z, argument of z minus 1. If you look into this locus, we already know that this is a locus of minor arc. So now this minor arc, if I draw, is going to look something like this. So if I look into this, this is the minor arc, and what the portion that we need to consider is the portion that is here, the smaller portion. So now if you draw both of these, you can see the common intersection of both of these is coming in the second quadrant. So our answer becomes a portion of the circle centered at 0, minus 1 by root 3 that lies in the second quadrant only. Now this talks about second and third, so this cannot be correct. This talks about empty set, this cannot be correct. And this talks about third quadrant, again cannot be correct. So even if you do not find this center, it does not matter, still you will be able to get the answer correct. Now this very interesting question came in 2019. In this question, what they're saying is set of all these points lie on which of these following locuses. So what you can do is we can rationalize it. So if I multiply by alpha plus I in numerator and denominator, I get the value of x plus iy. So if I simplify this, it becomes alpha square minus 1 plus 2 alpha I by alpha square plus 1 is equal to x plus iy. So the value of x comes out to be alpha square minus 1 by alpha square plus 1, and the value of y comes out to be 2 alpha by alpha square plus 1. So this is very interesting to observe that where this is going to lie. So now what we have to fundamentally do in order to get to the locus is eliminate alpha. That is our job that is left in order to get to the question. Now in order to do this elimination, if I do this very simple substitution, or if I can observe that if I somehow replace alpha with nothing but tan theta. So what is going to happen is here we get a formula of tan square theta minus 1 by tan square theta plus 1. And on the other side for the y we get is 2 tan alpha by tan square alpha plus 1, tan square theta plus 1. So what you can see is in place of x what we are getting is minus of cos 2 theta. In place of y what we are getting is nothing but sine 2 theta. So I can eliminate and write x square plus y square equal to 1. You can see that it comes out to be a circle whose radius is 1. Now this is a very intelligent question based on geometry of complex numbers and quadratic. So how to do this question? So what we are going to do is instead of z, let us put x plus iy. And in place of alpha, let us put p plus iq and simplify. If I do that, what I get is a times x square plus y square. And if you simplify the second part, it becomes twice of xp plus qy plus d equal to 0. And if I write this in the standard form, this becomes x square plus y square plus 2x p by a plus 2q by ay plus d by a equal to 0. What they're saying is this represents a circle. Yes, definitely it is a circle, but for this to become real circle, the radius of the circle needs to be greater than 0 and a cannot be equal to 0. These two conditions needs to be there, otherwise it will not be a circle. So if this condition is fine, now let us take the condition of r. So this becomes nothing but g square plus f square minus c. So g square plus f square minus c. Root of this is nothing but radius. This needs to be greater than 0. And if I put this, what I get is p square plus q square minus ad needs to be greater than 0. Now p square plus q square is nothing but mod of alpha whole square into addition needs to be greater than 0. So now if you look into the options, your second option matches perfectly. Now in this next problem type, we are going to look into the expression of conics in complex numbers. Now this whole idea is based on two very specific types of conics and two very specific types of expressions of conic. So let us say that if I consider an ellipse, for ellipse what we know is this property that if we have two foci as S1 and S2 and there is a point P, and if I connect this point P to S1 and S2 on this ellipse, the relationship was S1P plus S2P is equal to constant, and this constant is equal to 2a. So this was the relationship that we have seen. And also here also there were 2-3 cases that we need to understand. The cases was if k is equal to nothing but the distance between S1 and S2. In this specific scenario, it is going to become a degenerated conic. That would mean this will represent all the points between S1 and S2, or it becomes a line segment S1 S2. The next part was if this value of k is greater than S1 S2, then definitely it is going to become an ellipse. And the third condition was that if this k is smaller than S1 S2, then it will represent no locus. So it will represent nothing. Fine. So there are these three important scenarios and conditions that we need to consider. Now, if I consider the case of hyperbola, what we knew there was if we have 2 points S1 and S2 as foci, and then there is a point P, then in this scenario, the cases or the conditions were a little bit different. So let us say that this is a point here, and then we have this upper curve like this. So here the conditions were a little bit different. So let us write those conditions and then write the complex number avatar of those conditions. The condition was here nothing but S1P minus S2P mod should be equal to K, where K is nothing but equal to 2A. So this is what we knew. But there are three important conditions that we need to follow. One is if K becomes equal to S1, S2, again it becomes a line segment. And you can see that now this will happen when this line is on the other side of S1 and S2. So that part of line segment it is trying to represent. Another condition here is what will happen if K is smaller than S1, S2. So this is totally fine because in this case it is going to represent hyperbola. But if K is greater than S1, S2, in that case it will represent nothing. If I want to write the same idea in complex number, this first equation can be written as nothing but Z minus Z1 mod plus Z minus Z2 mod is equal to K. K will have the similar kind of condition. The value of K here, if is smaller than Z1 minus Z2 mod, will represent nothing. And if K is equal to nothing but Z1 minus Z2 will represent the line segment joining S1, S2. And in the third case, if K is greater than Z1 minus Z2 mod, it will represent nothing but an ellipse. Similar way, we can also extrapolate the other idea. Only thing that we need to do here in the second part is write this equation as nothing but Z minus Z1 mod minus Z minus Z2 mod is equal to K. And then you can also interpolate the same idea in the similar manner that we did for ellipse. So you don't need to remember these ideas. You need to understand the concept of modulus and remember what we learned in ellipse and hyperbola. This is not a question of complex numbers. This is essentially a question of conic sections properties. Now let us see what kind of questions JEE has asked on these ideas. If I look into this first question that came in 2022, what you will realize is all you need to do in this question is identify the conics, identify the basic geometrical figures, draw them on a normal coordinate plane and check how many points of intersection are there. So the first idea is to recognize this point. So if I draw this is a circle, we can easily recognize whose center is at a point 4, 3 and radius is equal to, this is very easy to identify. But if you look into this one, this comes out to be as an ellipse where Z minus Z1, if you compare with this equation, Z minus Z1 mod plus Z minus Z2 mod is equal to K, where this is nothing but twice of it. And for this to become ellipse, K also needs to be greater than Z1 minus Z2. That it is, because Z1 minus Z2 is 4 and this value is given as 6. So that is fine. So it is an ellipse. So once I draw this ellipse, what you will observe here is, you have drawn it, one of its foci will be at a point 0, 0 and another foci would be at nothing but 4, 0. So the midpoint of these two would be nothing but center. So our center is at a point nothing but 2, 0. Now what we are saying is, what we need to figure out is, see, if you look it from a geometrical point of view, the center of this is 4, 3. So if I actually draw it on the coordinate plane, this is going to look something like this. There is a line that is passing through one of the foci. This is one of the axis, this is another axis. And then if I look into my circle, and it is somewhere up here because it's 4, the x coordinates are matching. So it is in line with the other foci that we have. So our important consideration would be to find this point, that is the end of latus rectum passing through 4, 0. For this, what will require the value of B. Now in the question, what they have given is the value of 2A, that is given as 6. So from here, the value of A comes out to be 3. This part is fine. In order to find the value of B, what we have is the distance between two foci is equal to nothing but twice of A. So 2 times A into E will be equal to nothing but 4. So the value of E comes out to be 2 by 3. And if you simplify this, 1 minus B square by A square is equal to 2 by 3. So from here, the value of B square, if you calculate, comes out to be 5. So now if I want to find this extremity, this distance from here would be equal to nothing but b square by a. So if I find my b square by a, b square is nothing but 5, a is nothing but 3. So this point, and this is 4 comma 0, if I go 5 by 3, this point will come. So this is 4 comma 5 by 3. Now this is very interesting. Why? Because now if I overlap this circle on this diagram, let us see what happens. If I overlap this one, the center is at nothing but 4 comma 3. The radius is nothing, so it will dip down 2 units from here. So the point that is vertically below this point 4 comma 3 is a point 4 comma 1 here somewhere. So for this to happen, you can see that it will have to intersect at 2 points, and hence the answer becomes nothing but C option, that is 2. Now this very beautiful question was asked in 2023, and the biggest problem with this question is understanding what they're trying to say. So see, what they're trying to say is, if there is a point that follows this trend z plus 1 by z, where z is coming from this curve, then what is going to be the locus of that point? So let us say that this complex number ultimately will be equal to x plus iy, because we want to find the locus, and this is equal to z plus 1 by z. Now you can see that for finding the value of z here, we have another equation given here. What this equation says is mod of z is equal to 4. That means z lies on a circle like this. If z lies on a circle with a radius 4, and if I consider one point at an angle theta here, that is nothing but argument, this point can be written as 4 e raised to the power I theta on argument. So you can see that any z on this curve can be represented as 4 into e raised to the power I theta, which is also the parametric form of a circle. If I do that, here x plus iy can be written as 4 e raised to the power I theta plus 1 by 4 e raised to the power I theta. And if I simplify this, it is 4 e raised to the power I theta plus 1 by 4 e raised to the power minus I theta. And again, if I simplify this, what am I going to get is 4 cos theta plus 4 times I sin theta. And the next part becomes nothing but 1 by 4 times cos theta minus 1 by 4 times I sin theta. And now if I write x plus iy, that is nothing but 4 plus 1 by 4 times cos theta, and then 4 minus 1 by 4 times I sin. Value of x comes out to be nothing but 17 by 4 cos theta, and value of y comes out to be nothing but 15 by 4 sin theta. So if you find equation of this curve, it comes out to be an ellipse. And if I plot this ellipse, you can see that this is an ellipse with center at origin and is in this shape. So this is how my ellipse look like, with the center at 0, 0. And the value of a, if you from here, if you write the equation is coming out to be x square by 17 by 4 a square plus y square by 15 by 4 square is equal to 1. What we have done is cos square theta plus sin square theta equal to 1. Cos theta we find from the first equation, sin theta from the second equation, and we have got our answer. Once we plot it, you can see that the value of a here is 17 by 4. Now 17 by 4 is slightly greater than 4. And the value here is nothing but 15 by 4. So this value or distance is 15 by 4. This distance is 17 by 4. If I overlap with my curve that was earlier a circle, then you can see that from here they will have 4 points of it. And hence A option becomes correct. Now this extremely simple question came in 2020. In this question, what we have to do is what they're saying in the question. So just put the value of modulus here, and this becomes x square plus y square root. This becomes minus of x is smaller than or equal to 1. So if I take my x on the other side, it becomes x plus 1. Now if I square it, what I get is x square plus y square is smaller than or equal to x plus 1 whole square. If I simplify, it is x square plus y square is smaller than or equal to x square plus 2x plus 1. X square and x square gets cancelled out. So y square is smaller than or equal to 2x plus 1. And this is given in option B. That comes out to be our answer. Now let us move towards the last problem type of this chapter, that is problems based on mixed concepts in geometry. Now let us see the first question that came in 2005. And I am very sure that this kind of question can again hit you this year in 2024. In this question, what they're talking about is a region that is given to us in the diagram, and they're talking about which of these following option is synonymous with the locus of this region. So now if I look into this, they have given this point P at minus 1, 0. And if I look into this point, if I take any point here, and if I want to write this vector, this vector is going to be nothing but z minus minus 1. So this becomes nothing but z plus 1. So whenever I'm looking into any point, that point is nothing but z plus 1. Now, what they are showing is the region that is at a certain distance from this point. Q they have given us as nothing but minus 1 plus root 2 comma root 2. R they have again given us. So if I want to find the distance of PQ, I can apply my distance formula and figure out this distance. So distance, if you see PQ, if you find the distance, it comes out to be nothing but root 2 whole square plus root 2 whole square root, and that is nothing but 2. So you can see that this distance of PQ is nothing but 2. So this is the circular radius between P and R. That is what we can understand. Now once you've understood this, if I'm talking about a region that is outside the circle, it is nothing but z minus z1 mod is greater than 2. Here z1 is nothing but minus 1. So this region becomes z plus 1 mod is greater than 2. Now let us look into the option. You can see this option, first option, and third option talks about this area. So this B and C, D cannot be correct. We have eliminated two options. Now the second part is they are talking about an arc, a circular arc kind of a thing that is getting formed. So now for this, we have different types of arguments. So what we are, if I take a number, you can see that the maximum argument or angle here is nothing but pi by 4. And the minimum is minus pi by 4. So I'm taking those numbers whose argument lies between minus pi by 4 and pi by 4. You can see that from this point of view, this option also, this part also matches, this does not matches. And so our option A becomes correct. So you should have 2-3 ideas for doing such kind of questions. One is the logic of modular should be clear. What does this means? This would mean a region outside circle. This would mean a region inside circle. These are the first set of ideas that should be clear to you. Second is the argument based ideas. So if I'm writing argument of z is equal to pi by 4, it represents a ray. This we already looked into earlier. But if I write argument of z lies between 0 and pi by 4, it is the region between two rays like this. So this is 0, this is pi by 4. So whatever points comes between these two lines and are going to have an argument or angle between 0 and pi by 4. So this is another idea or the third idea that should have in your mind for doing such kind of questions. Now here I have given for z minus z1 will shift the origin to that point. If you remember these 3-4 simple tips, all such kind of questions you can do, and I'm sure one question can come on this idea in 2024 this year. So we might have seen multiple such questions in the exam where they talk about general terms Z, A, B, C. So there is a very small and a very clear trick to solve all such questions. Consider some value of Z and preferably something that will make it stand apart. Let us say that Z is equal to 4, and obviously it is a complex number. And since the answer is also given in terms of Z, we can also substitute Z equal to 4 in the options and see what the options are. So correspondingly, my options modified to 1, 8, 1 by 2, and this if I calculate, it is nothing but 1 by 2 into 4 square into root 2 whole square. So this becomes nothing but 16. So you can see that my options also got modified by putting Z equal to 4. Now I can easily plot these points considering them as coordinates. So this point becomes 4, 0. This becomes 4i or 0, 4. And this last point becomes nothing but 4 plus 4i or 4, 4. So you're talking about a triangle when you join these points. That triangle is this triangle. If I apply the formula of half of base into height, so 4 into 4, the answer comes out to be 8, and that matches with my option number 2 or B option. Let us see this next question that came in 2022, and is the combination of 2-3 ideas. So one is this circle. So if I draw this circle, it is a circle whose center is at origin. So my axis will pass something like this and like this. And the radius of this circle is 2. So this point becomes 2i. This point becomes minus 2i. And then they're talking about, if you carefully observe, a locus that is z minus I mod is equal to z plus 5i mod. We have already talked about this. This is nothing but an equation of a perpendicular bisector. So if I mark these points, my I would be somewhere here. My minus 5i would be somewhere here down the line. And if I talk about their midpoint, it is a line passing through this point minus 2i. We are talking about this line. You can see that the point that satisfies both the curve is only one point, this point. If I talk about this point in coordinate plane, it is nothing but 0, minus 2. So what they are asking is, this 0, minus 2 is satisfying which of the following options? The question is very simple. So if you satisfy all the options, you will find that your C option is satisfying it, and hence it becomes the answer of this question. So if you can interpret complex number in terms of coordinate geometry, your solution becomes extremely short and fast, and you can do such kind of questions in 30 seconds. If you put everything in z is equal to x plus y, it is going to take a lot of time. Now, this beautiful question came in 2021 that combines the idea of relation between roots and coefficients from quadratic, the idea of geometry of complex numbers, and some basic manipulation to get to the answer. Let us see what does this question says. So let us say that there are two roots here. So if you have two roots z1, z2, then the sum of roots is nothing but minus a, and the product of roots is nothing but equal to 12. This is one set of results that we are getting from the relation between roots and coefficients. Now what they're saying is, if I take this roots z1, z2 and origin, they form an equilateral triangle. Let us say that the equilateral triangle is of this format. So this is my z1, this is my z2, and since this is equilateral, this is pi by 3, and these both sides are equal. So if I apply my rotation, because it becomes a standard case of rotation, I can write z1 by z2 is mod of z1 by mod of z2 is equal to e raised to the power I pi by 3. And since it is equilateral, then mod of z1 should be equal to mod of z2. So what we get is z1 by z2 is equal to e raised to the power I pi by 3. So you can see that rotation came into picture. Now if I square this first equation that we had, so z1 plus z2 whole square will be equal to a square. And this becomes z1 square plus z2 square plus 2z1 z2 is equal to a square. And now if I divide this by z1 z2, something very interesting happens. So I have divided this by second equation. This becomes z1 by z2 plus z2 by z1 plus 2 is equal to a square by 12. Now if I put the value of z1 by z2, it is e raised to the power I pi by 3. The second one will become e raised to the power minus I pi by 3 plus 2 is equal to a square by 12. And now if I simplify, I get my answer really fast, because this is nothing but sum of number with its conjugate to twice of real part, that is 2 times cos of pi by 3. And if I simplify this, I get the value of a here. So if I do this, this is 3 into 12 is equal to a square. So mod of a is nothing but 6. You can see that how beautifully this question has been framed. There is a part of the question that comes from rotation. So this part comes from rotation. There is another part of this question that is coming from quadratic, and then this is manipulation. This specific manipulation that we are doing here is again very beautiful. You have to square and then divide. So multiple parts coming together, and small lot of results, like here also if you use this result. So multiple results coming together to make a very beautiful question. Now let us look into this last question of our discussion that came in 2021. It talks about 3 different kind of locuses. If you look into the first locus, it is nothing but the region inside a circle. So if I draw the circle, it is x minus 1 whole square plus y square is equal to 2. The second region talks about the real part of this. So if you multiply, what you will get is x plus y. What they are saying, this is greater than equal to 1. And the third locus, they are talking about y is smaller than equal to 1. Now if I look into the plane in which we are drawing all of these, so let us draw the third one because it is the simplest one. So what we are talking about, a region that is smaller than or equal to 1, where y is. So what we are talking about is this region. Let me highlight it. So this is the region that we are talking about, but that is below this line. This region we are talking about. Now what they are doing in the next one is, they are giving us a region that like something like this. So this is the equation of this line, x plus y equal to 1. And if I put 0, it is not satisfying. So we are talking about this region above this line. So if you look into this region, it comes out to be something like this. So we are talking about this region here. Now if you draw the third part, that is the circle, it has a center at 1, 0. So this is my 1, 0, and the radius is root 2. So if I try and draw it, it would be something like this sort. But after drawing this, what you can observe is, it is not just this. We want the points that are inside this circle. So inside this circle, there are many points. So if I find the common area between all of these 3, you can see that this part would be common. Hence, there are infinitely many points that are satisfying all the 3 locuses. Hence, option C becomes the correct answer. If you like this video, you will also like Pragbee's unique approach to teaching students or guiding students for the last mile journey. So if you are a student who has been preparing for 2 years and going to write this exam in 2024, this is one of the best ways and platforms that you can prepare with. Unlike other crash courses who focus on teaching 100% syllabus in just 2 to 3 months, which a student took 2 years to prepare, we have a different way to approach the problem. This process works on 3 very specific steps. In step 1, we start from you. What exact preparation have you done in the last 2 years, last 1 year, last few months? And what is the minimum amount of effort, areas, concepts and problems that required to be prepared to get a very good college from JEE Mains? In step 2, based on this customized plan that was prepared based on your strengths and weaknesses and the minimum path of least resistance that you can take to get into a very good college, we align you a one-on-one faculty, a faculty who is going to teach you as a student, keeping your needs into mind, where you are getting stuck in a topic, what kind of problems you cannot solve, and how to solve those problems in a very efficient and smart manner and convert that topic into tangible marks in JEE Mains. In step 3, we attach you to a test series, a testing platform where you can test yourself for each and every topic that you're preparing. You can write full syllabus test and get an understanding that how this program is working for you, wherein the faculties can again sit with you and customize the plan based on your needs so that your score is getting maximized in JEE Mains exam. Using this program, Ashish was able to maximize his score in JEE Mains and JEE Advanced and was able to get into IIT Madras Mechanical in just a matter of 3 months. If you are one of those students who think that he has got the potential, who can make it, and he wants to have a smart and efficient approach at this point of time, which can maximize his or her result in JEE Mains exam, you can apply for this program in the link given in the description, and somebody from my team will get in touch with you and help you out. See you until next one.